Professor Bialis here. In this video we're going to talk about section 11.6 and take our discussion from 11.5 a little further. Okay, when we dealt with 11.5 we were focused on graphing functions, quadratic functions, that were in that vertex form. Now we called it vertex form because we learned that h and k gave us the vertex. They literally gave us the ordered pair for the vertex when we shifted left, right, up, down. Okay? When we go and look at quadratics in just the general sense, typically we see quadratics given to us in this form. Okay? Now that right there is like a standard or general form of a quadratic. We don't have our vertex just staring us in the face. What we do have is that a value still in play. So a value is not an issue, okay? But without that h and k, we need to dig a little bit more to see where that vertex moves so we know the location of the graph, okay? So, how do we do that? Whenever we are looking for these values here, there's a very simple translation that uses the a, b, and c and then translates it to that h and k. The h is where we're going to start. H was always that left and right, or the x value for the vertex. That is going to be calculated with the opposite of b over 2a. Okay? Where that comes from is if you use completing the square to convert this into this position here is going to have this expression. It's simple as that. It's not something that is just randomly generated by somebody. It was just a simple algebraic presentation to go from this form to this form. Okay? Now, the next thing's a little bit trickier because it's presented to you in the book for k value as f of the opposite of b over 2a. Now, what that means is once you get this x coordinate for that vertex, that's your input. How do you get an output? Plug in the input. So if we take this opposite of b over 2a and plug it into the original function, we get the y value for the vertex, which is the k. Okay? So let's just jump into an example to see how this is going to play out. I want you to ultimately copy or mimic what we did back in section 5. It's just going to require a little extra algebra right off the bat that gets you the h and k as opposed to just pulling it out. That's the only difference between this and what we did in the previous section. So let's look at an example. Let's say we have something like this. Now that is in ABC format, okay? When we're graphing, we still want to be able to identify the A, H, and K, okay? The A value is always that first number you see, no matter what format you're in. So A value is 1, and just like before, no change. That's not going to do anything to our graph. Now the H and K are not just looking at us in the graph, so we got to calculate it. If we're in ABC format, H is going to be found with opposite of B over 2A. Opposite of B over 2A. That is a formula you guys need to know. And then all I do, opposite of B over 2A. 4 over 2 is 2. I have an H value of 2. When the H is 2, that tells me to go right. Now again, that K value is the Y coordinate of the vertex. It's the output of the X coordinate of the vertex. So what I'm going to do is I'm going to take this 2 and I'm going to plug it in to the original function. That's it. So I'm going to take that and I'm going to plug it in like so. 4 Minus 8 is negative 4. Minus 5 is negative 9. As a k value, takes me down. That's all there is to it. That is the only new part to this section, is calculating the h and k as opposed to pulling it out of the formula. Okay? The interpretation of the h and k is no different than what we did in the past. So don't overthink that. Don't try and reinvent that. It's just how we can calculate that h and k. Nothing more. And then the graph is the same. So I'm going to start with that parent function. Don't forget to do that. I want you to keep doing that. A lot of times, stuff like this, you think to yourself, I got it. It's the next section, I got it, I don't have to do it. That is a very dangerous way of thinking. And sometimes even teachers do that. They say, okay, we tested on that, so you guys got it, so now we can shorthand it or use the calculator for it. That's not possible for it to really be ingrained in our brains over a week or a month or even a semester or even a year. You've got to keep practicing. Keep those basics down until you're maybe 2 courses in the future. Then you can start really incorporating those shortcuts. I know that's tedious. I know that takes a lot of patience, but it's totally worth it because in the long run, you really understand and remember and keep a hold of all that information. Okay, so I'm going to go back here, finish this. Here is my parent function. And then, same as before, a value is nothing, so I'm going to start with that h and k. So I go 2 right and then 9 down. 2, 4, 6, 8, 9. There's my new vertex. The shape of it's not changing because the a is 1. So I have my normal pattern of right 1, up 1, right 2, up 4, right 3, up 9. And then I go the other way. And here's my new graph. All I did was shift over, down, end of story. Okay? Let's look at a few more examples. Let's say we have that. Okay, so in this case, the a value is sitting out in front, so negative 3. H is that opposite of b over 2a, which is positive 2 over 2 times negative 3, which is negative 1/3, because those 2's just cancel out. Okay? Now, what we have to do from there is plug that in. So f of negative 1/3. So we have negative 3 times negative 1/3 squared minus 2 times negative 1/3 plus 8. Again, you can use your calculator there, but this is a good place to practice your fractions a little bit. So we've got negative 3 times 1/9, and then you have a plus 2/3 plus 8. This is going to be a negative 1/3 plus 2/3 plus 8. That's 1/3 plus 8, which is 8 and 1/3. Since we're graphing here, mixed numbers aren't a bad idea. Okay, so I have 8 and 1/3 for that. And guys, as you can see, this looked really bad at the beginning, but it worked out fairly nice at the end. All those thirds just coming together nicely, and it's really, really not a big deal. Okay. Now let's talk about what those are going to do to the graph. Okay. One thing I forgot in the last one, that parent function. Don't forget, put that x squared on there. Okay, just so you don't forget that. So h is negative, so we're going left. K is positive, so we're going up. And then we have that a value of -3. Okay, now there's two parts to that. The negative is a vertical flip, and then the 3 is a vertical stretch. And that's what's happening to our graph. Okay. Now, in this section, a lot of times they talk about intercepts as well. Honestly, guys, intercepts, all you're doing is x-intercept, y = 0, y-intercept, plug in x = 0, and you can find your ordered pairs that way. That is an old topic. If you guys have questions, please reach out and I will talk about that with you. But intercepts, if you'd like, you could look at, I believe it's section 3.2 in these videos that I have posted. 3.2 or 3.3, you can look up a big discussion on intercepts, but it's no different whether it's quadratic, lines, rationals, anything. That's where you start, you plug it in, and you get your points. Okay, so let's go back to this graph. Standard graph or parent graph, 1, 1, 2, 4, 3, 9. And then same thing going the other way. Dashed curve, just to show that this is a guideline as opposed to the actual graph. I'm going to start with my vertex. So I'm going to go 1/3 left and then down 8 1/3. So 1, 2, 3, 4, 5, 6, 7, 8. And I end up in this like little corner there. So let me check that one more time. 2, 4, 6, 8 1/3. Okay, this position is going to be very crucial. So there's my new vertex. Now I have to do all of that transformation part over there. So I go back to my normal pattern. 1, 1, 2, 4, 3, 9. I multiply each of those verticals by the a value of -3. So I multiply by -3, -3, -3. It's a -3 here, -12, -27. Probably 2 of those you're not going to fit on your graph. That's okay, that's not the end of the world. You have them there though, just in case they do fit. Don't just say, oh, it's too big, forget about it. But if it doesn't fit, not the end of the world, okay? So, what we're going to do is take this and then move, instead of write one up 1, write one down 3, because it's a -3. Don't let the fraction throw you off. You are looking at positions and you are moving not one grid line, but one lane over 3 lanes down. Let me show you what I mean, okay? From here, I want to go 1 lane over. I'm still in that like top right corner, and then 1, 2, 3 lanes down. And there we have it. Notice I'm in that same position within that box. Okay, so fractions really come down to positioning within that either grid line or in that lane. Okay, lanes in between of those. And then I would go right 2 down 12, but there's no way I'm going to fit that, so that's okay. Then other way, I go 1 lane to the left, 1, 2, 3 lanes down. And there we have it. And there we go. And look at what I did. I went left 1/3, down 8 1/3. I flipped it, and then it was stretched down as well. So again, guys, fractions, you got to be careful. This isn't like, oh, fractions are no big deal, piece of cake. But you have to just take your time with it, and they usually end up very, very nicely for you. Okay? That is pretty much it in terms of the graphing aspect of this section. The only new part is how we calculate the h and the k. After that, how we interpret it, how we translate it to the graph, same as section 5. Okay, one last idea that they do present in this section is the idea of minimum and maximum. Now there's a very big discussion with that when you get into like a college algebra or pre-calc where you talk about local mins, local max, absolute mins, absolute maxes. But here we're going to keep it pretty simple because we're talking about quadratics. the graph of a quadratic will either end up like this or like this. Simple as that. Now, when it is like this, we can see that there is a low point to that graph. This low point is called your minimum. When the graph is like this, what do we have instead? We have a high point to the graph. This high point is called your max. Now notice, either way, min or max, what did we just find? In both cases, that's your vertex, whether it's there or there. All that determines whether that vertex is a min or a max is if it's opening up or opening down. Now, how can we tell that just by looking at it? I don't have to graph that every single time. Remember, that opening down happens when we flip. So, if you have an a value that is bigger than 1, okay, I'm sorry, bigger than 0, meaning it's positive, that means that graph is going to be opening up. You should be looking for a minimum value. Now be careful, because a lot of times we think up maximum, but up is actually going to give you a minimum. If the a value is less than 0 or negative, that means that graph's going to be opening down. We should be looking for a max. Okay? Or I should say, when we find the vertex, we will be finding a max. When we find the vertex here, we will be finding a minimum. Okay? So let's look at just a really quick example of this, because it's not just find that vertex. We need to interpret the parts of the vertex, and I'll show you that in a minute here. I am on practice 5. This is on page 711. So it reads, a ball is tossed upward from the ground. Its height in feet above ground after t seconds is given by the function h of t equals negative 16t squared plus 24t. Find the maximum height of the ball and the number of seconds it took for the ball to reach the maximum height. Okay? Now, we read through that problem. Again, you have someone throwing a ball in the air. Now, when you throw a ball in the air, what does it do? It goes up, and then it comes down. Okay? That right there gives you that general shape of the trajectory of the ball. Now, also, we can get that basic shape by looking at this function that they gave us and seeing that the a value is negative. So we know we're going to have a parabola opening down. Therefore, we're going to have a max, which they reference in the problem when they say find the maximum height. And what time does it take to reach that maximum height? Now, regardless of it being a max or a min, okay, we know it's a maximum, but regardless of that, we need to find that vertex. So this right here is not A, H, and K. This is A, B, and C format. So if we're looking for the vertex, really all that matters is the H and the K. Okay, that told us the vertex in vertex form. That's why we called it that. So H is going to be the opposite of B over to A. Let's plug that in and calculate. Opposite of B is negative 24 over 2 times negative 16. Two negatives make a positive, so it's 24 over 32, which is 3 over 4. Now let's hold on to that for a second. Then what we do is plug that in. Okay? Work that out. First of all here, 4 goes into 4 once, 4 goes into 24 6 times. So we have an 18. Now be careful with this, because this 3/4 squared is 9 over 16, which is actually nice because that's just gone. So we got negative 9 plus 18. That gives you 9. So we have a K value of 9. So if we were graphing, we would say this goes to the right, that goes up. But what we care about now is that the vertex is 3/4, 9. Okay? Now we need to interpret that, because they ask us two things. What is the maximum height, And when does that happen? Okay, I throw that ball up. How high does it get? That maximum height is my output, because that's what I'm measuring with this function. My output is my y value, which in this case is k. So this k value, this y coordinate of the vertex, tells me a location of that ball. That is the highest point it reaches. So my maximum height is 9 feet. Now what about the second part of the question? When does that happen? That's talking about a time. The t, that was your input. That was your x value, or in this case that h value. Okay? So that time right there tells us that we're going to reach that 9 feet after 3/4 of a second. Now be careful, because they may only ask for one part of that. They may say, you have a ball being thrown up in the air, here's your function, when does it reach its maximum height? If that's all they ask for, once you get this h, you're done. That's when it's happening. Okay, but or they may say, what's its maximum height? Then you get your 9, and then you're done there. You don't need to reference this if they don't ask for it. So when you find that vertex, when they say min or max, find the vertex. That's all you're doing. But you need to make sure that you are interpreting those two values within that vertex correctly. So be careful with that. Read the problem. Read your variables. Okay, input is your h, output is your k. Okay, that's always going to be the case. Input h, output k. Okay, that will always be the case. Just make sure you're answering what they're asking for. Okay, so again, this section we talked about a different way of finding that h and k when we're given the ABC format of a function, that opposite of b over 2a, and then plug that in. After that, you're interpreting it the same, you're graphing it the same, nothing different from there. The other thing was this whole idea of minimum maximum. Really, it's find the vertex, but we're just interpreting it as a minimum opening up or a maximum opening down. Beyond that, same old stuff. Okay, so don't overthink it. Be careful with all of this. Don't get lost here. Make sure you're circling your final number so you don't lose it. And work hard. Let me know if you have any questions, and I'll see you next time.